we're combining a couple sections because this should be somewhat of a review. We're combining a few sections just because section 7 is evaluate an expression. So we're dealing with just our order of operations, which we've already covered. So we'll just briefly touch on that again. And then section 8 is on solving equations. Our book calls it the do, undo, and we're going to look at it more like as a specific algebraic standpoint instead of looking at all those tables that they have. So just a quick review. Remember our order of operations to decide what to do first as you go through an expression. Follow your PEMDAS. Remember, start with the P, the parentheses. Always do things that are in parentheses or brackets first. Next thing we always do is exponents. So anytime you see an exponent, that should come right after your parentheses. Then the M and the D go together, correct? So we multiply and divide. Do I multiply before I divide? No. I multiply and divide from left to right. So once I'm done with all my parentheses and all my exponents, then I look to the left side and I go through and I start multiplying and divide from left to right. And I shouldn't do any addition and subtraction until the very end, unless they happen to be in parentheses. And for adding and subtracting, we do the same thing. Add and subtract left to right. So remember, don't ever forget your PEMDAS, your order of operations. We use that forever in mathematics. So evaluating expressions, the biggest thing is when you're given variables and you need to plug in for them, just to be careful. So for example here, it says evaluate the expression. A is -4, B is 6, and C is -3. And then you have this expression 3b minus 9a equals c squared. So let's plug in all of our variables here. So first off, B is 6. I'm going to go ahead and plug that in right here. So some of you might be able to take 3 times 6 right off the bat. That's totally fine. I'm going to rewrite it. I'm going to go 3 times 6. Remember, anytime you plug in for a variable, write it in parentheses. And then I have this -4 that's going in for the A. But just be careful. I have a minus 9a. So minus 9 times -4. So if you try to do that part in your head, it's easy to make a mistake. And you'll see why in just a second. And then lastly, C is -3, so we're going to go ahead and plug that in right here. And just like I said, use parentheses whenever you plug in a variable. So -3, well, did that square, does it go inside the parentheses or outside? Well, it's outside the C, so let's put it outside the parentheses. That's important. That's going to make a difference. So those are some key things. Just be careful when you plug in. So now let's simplify this guy here. Well, 3 times 6 is 18. That's good. And then think about this here. You can either do that -9 times -4 and get -36, and then take minus -36. That's totally fine. Well, what's minus a -36? That would be really add the opposite, right? It's really plus 36. What I like to do is I like to include this minus sign with my 9, so I'm thinking -9 times -4, which is a positive 36. You can go either route, but just be very careful with that. And that's where it's easy to make that mistake if you try to do this right off the bat mentally. And then we put that all over, well, -3 squared. So remember, that's really -3 times -3. So if you type it in your calculator, make sure you use parentheses. So that should be a positive 9. All right, and so 18 plus 36, that gives me 54. And then we divide by 9 to give us 6 for a final answer. So just be very careful as you plug in for your variables. All right, when solving equations, I got 2 core rules that I always follow. Okay, so get these down. The first one is do the inverse of what's being done, okay, to the variable. I say that all the time. I look at, what are you doing to the variable? We'll do the inverse. And we'll look at the inverses here in a second. And number 2 says, whatever you do to one side of the equation, always do to the other. So basically, find your equal sign. And whatever you do to the left side, you always have to do to the right side, right? It's kind of like, it's got to keep it balanced at all times, right? So if I look at all my different types of operations, let's just look at the first 2. Now let's just look at them all. I lied. All right, for addition, the inverse would be what? If you're adding, the inverse would be, subtracting. Well, that's just the opposite. If you're subtracting, the inverse would be adding. Okay, pretty straightforward. I think we could go through this next part too. The inverse of multiplication is dividing, division. And the inverse of division would be multiplication, right? They're kind of opposites. What about squaring and square rooting? Well, they kind of go together, right? If I square a number, for example, let's say I take 4 and I square it, that gives me 16. Well, if I'm going to go backwards and get back to 4, what would I do to that? I would square root it, right? So those are inverses. So whenever you see squaring, the inverse would be square rooting. And when you see square rooting, the inverse would be squaring. So what I mean is, for example, if I have an equation, let's say I have the square root of x equals 6. And I wanted to solve for 6. Well, some of us can think, well, the square root of 36 is 6. So that you know that x is 36. But to get rid of this square root symbol so I can get to my x, right? Because right now I'm square rooting x. I do the inverse of what's being done. Since I'm square rooting, the inverse is squaring. And whatever I do to one side, I do to the other. So the square root and the square kind of cancel each other, and I'm left with x, and 6 squared is 36. So that's how I would solve. So that's where the inverses come into play. And so you just have to be careful when you use your inverses depending on what's given. So I always go and find my variable and make sure it's on one side, which it is. It's right here on the left side. Now there's multiple ways to solve for x here. So we're just going to look at one way, but just know that there's multiple ways to do this. So if I was just given like negative 2x plus 4, and that was equal to whatever, let's just make some up, 10. Right off the bat, I'm multiplying by a negative 2 with the x, and I'm adding a 4 to the x. Well, which one do I have to get rid of it first? I always think if there's something like attached to the x, I have to do that last. So there's this negative 2 is attached to it. I almost work backwards in my PEMDAS. That's a good way to think of it. So work backwards for your PEMDAS when solving, if you're solving for a variable. So I'm going to deal with my adding and subtracting first. So I would just minus that 4 over, right off the bat. Well, can I minus the 4 up here right away? I can't. Because first of all, it's in parentheses, and second of all, it's on the top side of this division bar. So the first thing I have to do is get rid of this fraction bar, this division bar. Well, how do I get rid of division? Well, remember, do the inverse of what's being done. So what's the inverse of dividing by 5? Well, that would be multiplying by 5. And whatever I do to one side, I have to do to the other. And why would that help me? Why would multiplying by 5 help me? Well, if I imagine 5 is really 5 over 1. And if I look at these, the 5s would cross-cancel with each other, right? So that's why when you multiply by 5, they just eliminate each other. And now you're just left with that negative 2x plus 4 minus 6. And then over here, I also have to multiply by 5, so I get my negative 40. Okay? So that's what I look right away. I notice that the x is on the top side of the fraction, so I got to get rid of the fraction. Well, how do you get rid of a divide by 5? You multiply by 5. And that just cancels with the denominator. All right, so now let's take a look. Are these parentheses important? Do I have to have them there? I actually don't. Since this is a minus 6, I wouldn't even really need these parentheses. If it was times, then they're important. So there's two ways to do this. I could either just combine those two and say negative 2x and add the plus 4 and minus 6 and say minus 2. I could do that. Or another thing is I could just get rid of this minus 6 right away. Well, how do I get rid of a subtract 6? Yeah, do the inverse. Add 6. Whatever I do to one side, got to do to the other. So those cancel. So now you're left with your 2x plus 4. You don't need your parentheses anymore. And negative 40 plus 6 is negative 34. And then we work through. So what are you doing to your variable? You're multiplying by negative 2 and you're adding 4. So remember, always deal with the adding and subtracting first when solving. Work backwards. So I got to subtract 4. Whatever I do to one side, I do to the other, right? So those cancel each other, and we're left with negative 2x. Bring your equal sign down. And negative 34 minus 4. If you're not great with mental math, grab your calculator. That's okay. But it should give you a negative 38. All right, a negative and a negative. Add up to a bigger negative there. And lastly, we're multiplying by negative 2, so the inverse is divide by negative 2. Whatever you do to one side, do to the other. Negative 2's cancel. And we're left with x equals 19. There we go. So just follow those rules. Do the inverse of what's being done by working backwards with your PEMDAS, right? But sometimes it's not totally like that, right? So I had like this fraction bar right here. I had to get rid of that fraction somehow. So remember how to get rid of dividing is you multiply, so on and so forth. So just some rules to follow, and whatever you do to one side, do to the other. Let's try another one that's very similar to that. So same thing, the variable's up top, so I have to get rid of this fraction bar again. So what's the inverse of divide by? This is right, this is a divide by 6. Well, multiply by 6. Whatever you do to one side, do to the other. So those 6's cancel, and you're left with 18 minus 2. Just keep my parentheses. I haven't done anything there yet. And 15 times 6 gives us 90. All right, there's two ways to do this next step. One way to do it is I could distribute this negative 2. That's totally fine. Okay, let's actually do it both ways. I'm going to, over here, in red, I'm going to distribute that negative 2. So I'd still have my 18, and then I would take this negative 2 and distribute it to the x and the 3. So negative 2 times x is negative 2x, and negative 2 times 3 is negative 6, and that's still equal to 90. Okay, so that's one way to do it. The other way to do it is I'm just going to rewrite this guy. 18 minus 2 times x plus 3 equals 90. Okay, we'll come back there. Let's go back to where I just distributed. Well, what could I do next? Remember, you always want to simplify a side of the equation if you can. So if you notice this left side of the equation, do you have any like terms? Yeah, I have an 18 and a negative 6. Can I combine those two guys? Sure, what's an 18 and a negative 6, or an 18 minus 6? That would give us 12. And then I still have, my negative 2x, so I got to bring that down. And then I bring down my equal sign, and I bring down my 90. Okay, so always simplify when you can. Well, now let's take a look. We're multiplying by a negative 2. Be careful. The sign that's in front goes with that term. So this is a negative 2 that's being multiplied. Well, this 12, is that being subtracted or added? It's kind of hard to tell. You want to look at the sign that's in front. Well, there is no sign. So we assume that it's a positive 12, a plus 12. So what's the inverse of a positive 12? Yeah, a negative 12. So be careful with that guy. And whatever you do to one side, you do to the other. So those cancel, and I bring down, don't forget your negative, bring down your negative 2x, and that equals 78. And then lastly, we're multiplying by negative 2, so the inverse is divide by negative 2. Whatever you do to one side, do to the other. And x equals negative 39. Right? A positive divided by a negative is a negative. Okay, let's see if we get the same thing in this other guy by doing a different method. So instead of distributing, let's take a look. I have multiplication right here. And then I have like addition and subtraction on the outside. So I want to get rid of, remember, work backwards. I want to get rid of adding and subtracting. So I want to get rid of this 18 here first. So how can I get rid of this 18? I can't divide by negative 2 yet, because if I tried doing negative 2, I'd have to divide both these guys by negative 2. So I can't do that yet. So to get rid of this positive 18, we would subtract 18. Okay, see how that works? Because this is really like a positive 18. So they cancel. Then I have negative 2 times x plus 3 equals 72. Well, now instead of distributing that negative 2, it's just negative 2 times this whole thing, right? So can't I get rid of that? Right? We're multiplying by negative 2, so the inverse would be to divide by negative 2. And whatever I do to one side, I do to the other. So now those negative 2's cancel, and I'm left with x plus 3 and equals negative 36. And then, what's the inverse of plus 3? Well, minus 3. Whatever you do to one side, do to the other. And so x would equal negative 39. So I get the same answer. I just went about it two different ways. Okay? So sometimes there's multiple ways to do these.